Hello there guys, welcome back or welcome if you're just joining us for the first time. Last video talked about interference. Today we're talking about toll-like receptors. Now toll-like receptor or TLRs are pattern recognition receptors, PRRs. So their job is that it detects conserved microbial structures called PAMPs, which is pathogen associated molecular patterns. And in total they are 11. So they have no idea what like receptor 10 actually does. So we'll be talking about 10 today. Now, before I move on, let me just say something. I have a feeling going back to these like receptors and interferons in the future because basically I just read this because it helps in enhancing information. It's not really in my topic for information, but since it's involved information, I said, okay, let me read it and also teach it so I can know it better. But this is basically like just a touch of knowledge about these two topics. I feel maybe in future videos where I have learned more, I might come back to these videos and talk more about it. Who knows? Anyways, let's start with this first toll-like receptor. Now, TLR1 and TLR2 form a dimer that responds to GPI accory proteins, which are found in parasites, and also to lipoproteins. TLR2 and TLR6 also form a dimer which responds to zymosans from fungi and LTA from gram-positive bacteria. I can't remember the formula is LTA, but it's something acid. Then, then TLR4 is a homodimer and responds to lipopolysaccharides or gram-negative bacteria. TLR5 is also an homodimer and responds to a flagellin of E. coli. TLR11 responds to bacteria, which are mainly the ones that affect your urogenital system. And if this cell is a macrophage and does phagocytosis to have TLR3, which responds to double-stranded RNA, TLR9, a homodimer again, which also responds to cgpDNA, then TLR7 responds to single-stranded RNA, then TLR8 responds to double-stranded RNA. Now, all these activate signal patterns that we activate some transcription factors. We have AP1, IROF, and nuclear factor kappa beta. I think that's the name. The activation of these transcription factors leads to the production of protein signaling, interferons, tumor necrotic factor alpha, interleukin 1 beta, and interleukin 18. And all these things are to help enhance the inflammatory response.